Good morning, dragons. So I've pulled out a page from the Carnegie Learning textbook because this was one of my favorite activities in the last year or two, and I wanted to share it with you. So I provided the PDF form if you want to follow along. If you can print it home, that's great. If you can't, just watch what I do in the experiment. I know you're probably tired of watching a bunch of little videos of strangers trying to show you how to do this, and this experiment would have been really fun if we got to spend time together. It's only 5 questions long, but it's a lot of manipulating actual objects, which is so much fun in geometry, which is, for me, the best part about geometry is because it's hands-on. So I'm working with 2.3. So if you're able to print or you want to try to follow along, you can go back and look in the materials for today and find this investigation here. It's going to be called Lesson 2, all about that base, but I'm only choosing this part of Lesson 2. And in the back of Lesson 2, they have all these cutout shapes. And I already cut out the shapes I need because I want to show you how the formula for the area of a trapezoid works. So I'm going to get right to it. Alright. As you have seen, taking apart or decomposing a parallelogram forms a rectangle. You've seen that in a few videos. And putting together or composing 2 triangles also forms a parallelogram. Composing and decomposing can help you think about the shapes differently in order to determine their areas. In this activity, you will take apart and put together shapes to determine the formula of calculating the area of a trapezoid. The trapezoid is a quadrilateral with 2 bases, often labeled B1 and B2. You should have seen that on a previous video. The bases are parallel to each other. That means they never touch. The other 2 sides of a trapezoid are called the legs of the trapezoid. An altitude of a trapezoid is the length of a line segment drawn from one base to the other and perpendicular to both. That has a whole lot of fancy words that says this is a base, this is the base, this guy, altitude, he's really your height, and he creates right angles with your bases. So, in number 1, they want us to identify the bases and the height. Actually, it says just the bases, but just so you know, this is a base, this is a base. They're parallel. They're never going to touch. This is a base, this is a base. On this one, it's this one, and this one, and this one is this one, and this one. So and it doesn't really matter who is base 1 and who is base 2. And I didn't even pull out the answer key to see if they had an idea about that. But I have enough information already to find the area of these trapezoids because I could decompose them into rectangles and triangles. I could chop all this up, which you've done. You know how to do this. The height or altitude on all these is the perpendicular line segment that creates right angles with the 2 bases. Take a look at that for a second. You got 2 bases, very unusual, not like parallelograms, but you still only have 1 height. Now, if I were to calculate the area, it would be super helpful to give some kind of identification of who the bases are. Again, order really doesn't matter. I could call this one, gotta get my pen working for you, this one base 1, this one base 2, and call this height. I could call it base 1, base 2, height. These are not exponents, in case you were wondering. They're usually called like subscripts. They're just a label. They don't have any like value. Base 1, base 2, height. Base 1, base 2, height. You just have to make a choice, so if you're going to use the formula, you would know which numbers to put where. So that's identifying parts of a trapezoid. Now here comes the cooler part, is figuring out why the formula works. So in this investigation, they have 3 different characters, and each character does it different. So I've already cut out my little trapezoid pieces, and I will try not to lose them in the next 5 minutes. Okay. Marcus cut out and composed 2 trapezoids into a parallelogram to figure out the exact area of one trapezoid. Show what Marcus did. Okay, I can tell you what Marcus did. Marcus took one of these, and he pasted it down. Now, I'm going to put it right on the grid because I want it to line up because I'm going to prove a point in a minute. Okay, so he pasted one down, and it says he took 2 and turned it into a parallelogram, which means he took another one and he flipped it over and showed that a trapezoid is half of a parallelogram. So these were duplicates of one another. See? And then you just flip it and you fit it. How is this useful? Let me see if I can show you in a couple different ways. Let me add a third color in here to prove a point. Let's say I called this top portion base 1, and I called this bottom portion base 2. Okay? Call that guy base 1. Call that guy base 2. That's fine. That means if I duplicate and flip him, this is really base 2. Making this guy really base 1. Why do I care? Because I'm trying to prove that the formula for the area of a trapezoid is related to the formula of the area of a parallelogram. So in a parallelogram, area equals base times height. You might recall that. Well, take a look here. This parallelogram has a very unique base. We kind of like constructed its base. Its base is this whole thing, B2 plus B1, which you can flip-flop and call it B1 plus B2. So this particular parallelogram is B1 plus B2 times height. I hope you see that. And I can draw a height in there for you. Remember, we got the little rock climber. He's on the edge of the vertex, and he drops a rope straight down, creating a 90-degree angle. There's a height right there. So if you're following with me here, you could see that this plus this is going to make the base of the parallelogram. Multiplied by the height gives us enough information to actually calculate the area. But I don't want the area of the whole parallelogram. I want the area of half the parallelogram, because half of it is the trapezoid. So I really only want the area of this. Quick shading work here. That's really what I want. So when we look at the formula again, we go, okay, I've got a trapezoid I'm interested in, and it's half of this formula. So the area will be 1/2 all of this. You're just going to take all of this and bring it down, because you want half of that parallelogram that we just constructed. So that's one fun way to think about the formula. There's actually another, which is cool too. So maybe your brain grabbed onto this one and you're good. The next one is fun either way because I've only seen it a couple times. So Zoe takes a trapezoid what does she do? She folded the trapezoid so the bases align, cut along the fold, and rearrange the parts to form a parallelogram. Okay, it's not going to look the same. It sounds like it's going to look the same, and it's not. So I'm going to go back. I got another trapezoid here, right? And I'm going to highlight the top base as one thing. A little blue there. Then I'm going to highlight the bottom base as another thing, and a little green. And what Zoe does is she folds it. She folds it, which probably seems crazy. Okay, so I have a folded trapezoid. I lucked out. I folded right on a line. That worked out very nicely. Okay, I'm going to cut on that line because that's what Zoe's doing. That's what this character's doing. She's folding and she's going to cut right on that line she folded. And they say she takes these parts, these cut parts, and she creates a parallelogram. This is true. She's going to do this. She's going to paste this guy down. Try to line them up on the grid so if we needed to count, we could. Okay, that's as good as I'm going to get, I think. And then we have to put this piece with it, which would be here. Can you see that that shape is a parallelogram? I'm going to paste it down so you can see it better. There we go. That's not bad. All right, so what did she do? Originally, and I am going to peel this up momentarily. Originally, she had this shape, okay? Her little rock climber dude would have been like here. So your height would have been here. That's the original trapezoid. She cut it, she lined up the bases and cut it in half and recomposed it into a parallelogram like this. It's really neat. What happens to the height when she does this? How much of the height do you have? Like, what does it look like now? If you're thinking it looks like half the height, it is half the height. She like cut the height in half, which means if she's building the formula for the area of a trapezoid, she cut the height in half. She cut the height in half. 1/2 height. So 1/2 the height is now the height of the new parallelogram. And then base 1 and base 2, doesn't matter which way we do it, base 1 and base 2 still have to be added together. So the area of this new parallelogram, which is one full trapezoid, is 1/2 height times base 1 plus base 2. How is that different? Here we added a trapezoid whose area we really didn't want. This is we used only one single trapezoid and we want the area of the whole thing. That's the biggest difference here. Now remember, we can swap add-ins. Like if it's base 2 plus base 1, we're allowed to go flippity-flop base 1 plus base 2 because of the commutative property. So we want this whole area. We want this whole thing. So we want 1/2 height, because we chopped it in half, times the entire base, and the base now represents base 1 plus base 2. What else could you do if you were stuck? The trapezoid formula does not come naturally to our brains. This is not something that you memorize once and it's not like riding a bike. It's not like you're going to have memory of this. So let's say you get to a problem like on a standardized test and you don't remember the trapezoid formula. You can still chop up the shape. You could decompose it into a nice little triangle over here. You got one little guy here. You could chop it into another pretty little triangle here. And then you would have this leftover rectangle in here. So if you're stuck, chop it up into other pieces. Then you would go about your life by doing area of a triangle, area of a rectangle, area of another triangle. Add all the pieces together. Doing that, you're still going to get the correct solution. Can I prove it? Let's find out. I'm going to do some actual numbers here. If you have a calculator, feel free to pull it out. Alright, so the height is 1, 2, 3, 4, 5, 6. My bases are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Base 2 is 12. Base 1 is 1, 2, 3. Okay, I've got some good stuff here. So I'm going to do 12 plus 3. Area equals 1/2 height base 1 plus base 2. I've got 1/2 times 6 times 12 plus 3. All these numbers fit nice in here. Okay, 1/2 of 6 is 3. 12 plus 3 is 15. 3 times 15 is 45. Okay, so we're saying the area of this trapezoid is 45. Let's see if it happens again. All right, we've got height here is only 1, 2, 3 of the new parallelogram. I don't want to cut this in half twice, because if I do, I'm going to have a height of 1.5. This parallelogram is really this parallelogram that no longer resembles a trapezoid. His formula would really be height times base 1 plus base 2. So it would be 3 times 12 plus 3. Because this was 12 up above, we already counted, and this is 3 up above. If I do that, the area of this new parallelogram is base times height. The base is worth 15 because I have to add the 12 and the 3. And the height is worth 3 because I already indicated it. So now I have 45. Okay, good. Let's see. We're hoping for 45 because that's the goal here. So I've got, let's do the rectangle first. He's easiest. We've got 1, 2, 3 times 1, 2, 3, 4, 5, 6. We've got 6 times 3, that's 18. So the rectangle is worth 18 blocks. The triangle is worth 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The triangle is 6 times 6 cut in half, because he's half of a rectangle. So 6 times 6 is 36. Divide that by 2, you get 18. So this triangle has an area of 18. Last guy. We know this edge here is 6 because we've counted it a couple times. This is 1, 2, 3. So 3 times 6 is 18 divided by 2, which is 9. So I chopped it up into various shapes that I'm familiar with. I'm going to add their parts. 18 plus 18 plus 9 does in fact equal 45. So I hope this little experiment helps you explore how all the formulas work. They have a purpose. They make sense. And when you get to work with them hands-on, it's way more fun. The overall formula for number 5, to wrap it up, is the area of a trapezoid is 1/2 height times base 1 plus base 2. Thank you for joining me, Dragons. I'll see you soon.